Alright, so we've been talking about a lot of different normal forms. In this last video, I want to talk about, well, what are the relationships between these normal forms? When should you be aiming for one normal form versus the other? Because each normal form has different desires, has different trade-offs, different things that they're trying to optimize for. Alright, so the first thing I want to talk about is the Venn diagram of all the normal forms, okay? There are relations which aren't in first normal form, and those are terrible relations, and you should never do them, okay? By default, all your relations should be at least in first normal form, meaning all of your attributes are atomic. There's very, very few good reasons not to have your relations in first normal form. However, there is a subset of the relations that are in first normal form that are also in third normal form, meaning that they allow you to do lossless joins as well as to decompose your relations in accordance with functional dependencies. There's a subset of the ones in third normal form that are in Boyce-Codd normal form that basically say, I don't care about functional dependencies. I want to reduce all possible redundancy that I can with regard to functional dependencies. And then there's also relations in fourth normal form that are relations that say, okay, not only do I want to remove all redundancy due to functional dependencies, I also want to reduce all redundancies due to multi-valued dependencies. All right, so a way to kind of draw this up is to say, okay, what are the properties? What are the things that you care about for each type of normal form? So which of these normal forms reduce redundancy due to functional dependencies? Well, Boyce-Codd normal form does that, and fourth normal form does that. Which of these reduce redundancies due to multi-valued dependencies? Well, only fourth normal form does that. Which decomposition always preserves functional dependencies? Well, third normal forms does that. And which decomposition always preserves multi-valued dependencies? Actually, I haven't taught you a normal form that does that. Okay, so multiple choice question time, because once again, these are things, if you don't remember any other details, just remembering what are the properties of each of these normal forms, you can always come back to this class or some other textbook to look at what are all the normal forms, how do you check if you're in normal forms, how do you convert your relation into those normal forms if you want those particular properties. So if your database has lots of redundancy due to multi-value dependencies, which decomposition should you do? The one that you should do is the only normal form that I talked to you that reduces redundancy due to multi-value dependencies. That's fourth normal form. Okay, what if you have lots of redundancy due to functional dependencies? Which decomposition should you perform? Well, you probably want to do the decomposition into Boyce-Codd normal form, because Boyce-Codd normal form reduces redundancy due to functional dependency. You could also put it into fourth normal form as well, but that may not be necessary for your purposes. What about if you need to preserve functional dependencies? Which decomposition should you do? Well, then you would go to third normal form, because that's the one relation that cares about functional dependencies, preserving them at least. And what should you do to preserve multi-value dependencies? Well, I haven't taught you a good normal form that handles that. So really, none of these three are very good at handling this particular property. Okay, so one thing that you could be asking yourselves right now is, okay, you talked about first normal form, then you have third normal form, and Boyce-Codd is this kind of weird one, and then you have fourth normal form. Where the hell is second normal form? Well, second normal form is really kind of an archaic normal form that nobody really cares about. And in reality, first normal form really isn't talked about anymore either, because it's just really obvious. Alright, but just in case you guys really cared about what's second normal form, the rule is a table is in second normal form if it is in first normal form and no non-prime attribute is dependent on any proper subset of any key of the name. What? Well, a non-prime attribute of a table is an attribute that's not part of any key of the table. It's basically saying that if all of the attributes of the table need to be dependent on the entirety of the key. Otherwise, you should break it down into two subtables where each table has a particular key that directly determines all the rest of the attributes. And you don't need to know what this is. I will never ask you about it again. It's basically, I'm just sticking it here for all of those who are going, but you talked about first and third. There must be a second. There is a second. Nobody cares about it. Okay, well, if there's first, second, third, fourth normal forms, is there a fifth normal form or a sixth or 100th normal form? Yes. There are higher normal forms. There are fifth and sixth and more exotic ones than that eliminate other forms of redundancy that can be present in the database that I don't even understand. Those are well beyond the scope of this class, and to be perfectly honest, well beyond the scope of almost anybody who's using databases to hold practical data. Those sorts of redundancies that these higher normal forms are trying to handle are almost never present in databases, and so you never need to actually try to use these higher forms. I mean, in fact, I was debating whether or not to even talk about multi-value dependencies because they occur sometimes in databases, but actually not all that often. But I wanted to cover it just to show you that, once again, there are other types of normal forms. Okay, the other thing I want to make really clear with you guys is, well, what is normalization? Okay, so normalization is the process of converting a given database schema into one that conforms to one of the normal forms, be it first, second, third, fourth, Boyce Codd, any of those other ones. And the whole point of converting your schema into one of these normal forms is it removes some form of redundancy due to functional dependencies, multi-value dependencies, or other attributes if you care about the higher normal forms. Okay, so multiple choice question time. Is normalization a good thing? Okay, so let's go through one of these, each one. So, is normalization a good thing? Always, otherwise your database is broken? That's not actually true. Okay, you can have a perfectly functioning database that's not in any of these normal forms. In fact, if you guys were just creating a database from scratch, almost certainly it wouldn't conform to any of these normal forms. However, if you care about the properties that a normal form offers, a normal form is basically making a guarantee for you, saying, hey, if you want to be able to easily check your functional dependencies, put it in third normal form. Hey, if you want to make sure you don't have any redundancy that can be captured by functional dependencies, put it in Boyce Codd normal form. Hey, if you don't want to have any redundancy due to multi-value dependencies, put it in fourth normal form. If you're in one of those forms, you'll have the properties of that. And that's basically the whole reason why we're talking about this, is because often you don't want to have redundancy, or you want to be able to easily check your functional dependencies. And then making sure that you put your database into one of these normal forms makes doing so much easier. And you can argue that, hey, these normal form stuff isn't worth the time to do the research to refactor your database, and that could very well be the case. But if you're in the position to be able to decide how your database should be formed, putting it into one of these normal forms is almost always the right thing to do. And now you should say, well, by default, which of these things should you care about? In general, if you don't have a good reason to do otherwise, Boyce Codd normal form is kind of the default. It's kind of the one that you put your database into that reduces most of the redundancy that you would be concerned about. Being able to check functional dependencies is sometimes a useful trait, which is why I talk about third normal form. Or if you have data that has multi-value dependencies, then you almost certainly want to put it in fourth normal form. But in reality, which normal form you'd use is entirely up to what you need from your database.